Right, a couple more of these and then we'll move on to our next method. Here we're looking at what happens if we take the region bounded by sine and y equals 0, that's the x-axis, about the x-axis. Notice there's no limits given here. There weren't last time either. We know we're doing sine, which is shaped like that, and it intersects the x-axis at 0 and pi. Rotate that around the axis and we're going to get some sort of a like football shape. This is almost the same shape that I drew in the introduction to discs a couple lectures ago. So we've got like a football shape, and see our radius is 1, right? The highest point we get to is at pi halves of 1 and -1 down here. So looking at that box concept again, if I were to put a cylindrical box around this shape, which is silly, I don't think footballs come in boxes. Tennis balls come in cylindrical boxes, but not footballs. So if we find the volume of this box here, it's going to be pi times r squared, that's just 1 in this case, times pi, well, it's going to be pi squared. Pi squared is roughly 10. In fact, the square root of 10 was an early approximation for the value of pi. It's actually about 3.16, so this is just a little bit short of 10. And again, I'm going to guess that that football takes up approximately half of the volume of that box. Okay, setup hasn't changed. It's still going to be easy. And that is pi times the integral from the start to the finish, in this case 0 to pi, of the radius, our function, squared dx. Now we can't evaluate that this semester. You're going to do some trigonometric integration in Calc 2 in the fall, hopefully. Hopefully you'll be taking it in the fall. So what we're going to have to do is use our calculator for this here. And it's fairly easy to do. Let me zoom in a little. Right. All we need to do is put in sine of x squared. Whoops, sorry, not sine of x. Sine of x, close the parentheses, squared. That'll give us sine squared. And if we go to the graph's unimportant and not really terribly related to the picture we're looking at, but we know how to use this second trace 7 to go from 0 to pi. .57079, whatever. So we've got ourselves a decimal approximation here for, right, the decimal approximation is for this part. So what we end up with is 1.5707963 times the pi from out in front. And if you recognize that number, that's good. If not, you can just keep it a decimal approximation, but pi divided by 2 is 1.5707963. So what we really have here for our final value is pi over 2 times pi, which is pi squared over 2. So my guess was that it should be about half of the volume of that box. It ends up being exactly half the volume of that box. I've seen that before. No, I did not realize it was going to be exactly 1/2. One of these days, maybe I will remember that before I get to the end of the problem. Let's do one more. Y equals 3 over the square root of x, y equals 0, x equals 1, and x equals 9, rotated about the x-axis. So what the heck is this going to look like? Well, y equals 0 is the x-axis. 3 over the square root of x at 1, right? If we put a 1 in there, it'll be 3. As we put larger and larger numbers into here, it's going to get smaller. By the time we get to 9, square root of 9 is 3, 3 over 3 is 1, 2, 4, 6, 8, 9, down there. So it's going to be some sort of a decreasing curve like that. If we rotate that about the x-axis, we're going to get some sort of a sideways volcano-looking thing. And the volume of that is going to be pi times the integral from 0 to 9 of 3 over the square root of x squared dx. Or pi from 0 to 9, 9 over x dx. This is another one we can't do, right? This is x to the negative 1 power. If we were trying to do the integral of x to the negative 1 power, we'd increase the power by 1 and then divide by the new power. That's not going to work. So this is going to be another one we just have to pop into the calculator. So we go to put 9 over x in there, go to the graph, and do second Calc 7 from 1 to 9. And it'll give us 19.775. Multiply that by pi and we've got it. All right, so again, the setup is the important part. If you can evaluate it, then by all means evaluate it. If you can't, then just find a decimal approximation. And I apologize. We started at 1 here, from 1 to 9. In my integral, I put in 0. That should be the integral from 1 to 9. And if you really care, we don't care this semester, but you will next semester, we actually can do the integral of 9 over x. Turns out that is 9 times the natural log of x. The antiderivative of 1 over x is the natural log of x from 1 to 9. So we would get 9 pi times the natural log of 9 minus the natural log of 1. Okay, that would be our actual value for what we got there. Natural log of 1 is 0, so it would just be 9 pi times the natural log of 9. But again, you don't need to know that part until next semester. Next time, we're going to look at Warshers. See you then.